Hello class, let's do some practice questions for final exam part A. How many lone pairs are on the Lewis symbol of a sulfur atom? So to do this question, first you are going to go to your periodic table and find where the sulfur is, and you know it's in the 6th group, and you are going to write the electron configuration for sulfur. And by doing that, you know that it has 6 valence electron. When we write the Lewis structure for, when we draw the Lewis structure for small elements such as sulfur, first we assume there's like 4 coordination sites. So we have 6 electrons and 4 coordination sites. First, I am going to put 1 electron in each site, and then I have left 2 electrons, and I am going to pair up these 2 coordination sites. Now we are going to calculate, count how many lone pairs we have. We have 1, 2. The answer is C. What is the total number of valence electrons for OF2? So for this question, we are going to calculate the valence electrons. Oxygen brings in 6 electrons and fluorine brings 7 electrons, and there are 2 atoms. Then that makes 14 electrons, and total is 20 electrons. When the Lewis structure of SF4 is drawn correctly, how many lone pairs are on the central atom? So you need to identify which one is the central atom. When you look at the molecule, you have 4 fluorines bonded to sulfur. That means sulfur, your central atom. And then you are going to write your electron configuration and to find out how many valence electrons it has. It has 6 valence electrons. So when you have valence electrons, and it is the total count of non-bonded electrons plus the bonded electrons. So in this case, we have 6 valence electrons. This is the number we are going to find out, the how many non-bonded electrons, and the bonded electrons we have 4. So 6 plus x, 6 equals x plus 4, that makes x equals 2 electrons. If you pair it, that means you have single pair of electrons on sulfur. So the answer is B. What is the bond order of the NO bond in nitrosonium ion? So for that, we are going to count the total valence electrons in the molecule. Nitrogen brings 5 electrons, and oxygen brings 6 electrons, and since it is a positive charge, we are going to take off 1 electron. That means we have 10 valence electrons. So to be a molecule, you at least have to have just 1 bond. So we are going to make 1 bond first, and then we are going to count the valence electrons of nitrogen and oxygen. Nitrogen has 4 valence electrons and oxygen has 8 valence electrons. Oxygen is good in this case, but nitrogen is not. So we are going to take this lone pair and make another bond. So we are going to count the valence electrons again. Oxygen has 8, but nitrogen has only 6. So we are going to take this pair of electrons and make another bond. So we are going to count the valence electrons. Nitrogen has 8 now, and oxygen has 8. So this is a positive ion. So we are going to put brackets and put a positive ion. If you have a triple bond, your bond order is 3. According to the general trend discussed in class, which of the following atoms is the largest? The largest atom is the one has the largest atomic radii. So the trend for the atomic radii is the atomic radii increases to your left, and it increases, go down in a group. So you are going to place each one of these elements in your periodic table and see which one is the furthest down to your left. So you will find it's the radium. Which of the following atoms are allowed to have an expanded valence? Expanded valence means it can accept more than 8 electrons. So you can read these pages in your textbook for further information. So let's discuss this expanded valence. Generally, the atoms that have atomic numbers 13 or higher can have expanded valence. So let's analyze one by one. Let's take carbon first. Carbon, when you write the electron configuration, you see the valence shell is 2, n equals 2. When you have n equals 2, it can have L values 0 to n minus 1. That means it can have L values 0 and 1. These are the designation for this L value. 0 is your S and 1 is your P. And as you can see, it doesn't have any d orbitals or f orbitals. That means it cannot accept more than 8 electrons. This does not have an expanded valence. So let's go to iodine. When you write the electron configuration, you will see your valence shell is 5. That means n equals 5. Your L can be 0, 1, 2, 3, 4. So as you can see, it can have S, P, D, F, and G. Right now, it has like electrons in S and P. But in any case, if it receive more electrons, it have your D's, F, and G's, it can accept more electrons. That's what it means by expanded valence. So your iodine has expanded valence. And let's go to sulfur. Sulfur is the same, and you will see your valence shell is 3. If it n equals 3, you have L values 0, 1, and 2. That means you have d orbitals as well. You can accept extra electrons. That means your sulfur has expanded valence, and your answer is going to be D. What is the formal charge of nitrogen in NO2 minus ion? So first, let's remind two things. How do you calculate a formal charge? Formal charge equals to original number of electrons minus lone pair electrons minus half of your shared electrons. And let's count the valence electrons of this ion. Nitrogen brings in 5, oxygen brings in 6, and you have twice as that one. And because it's -1, we are going to add +1. You have 18 valence electrons. So we are going to put 18 valence electrons first and make 2 bonds and count. When we count the octet, you will see oxygen has 8 and it's good, but nitrogen has only 6 valence electrons. So that's why we draw this as resonance structure. So when you draw the resonance structure for this, you will see that your oxygen has 8 electrons, nitrogen has 8 electrons, and this oxygen has 8 electrons as well. Let's count the formal charge now. So originally nitrogen brings 5 electrons and it has one lone pair, that means 2 electrons, and we are going to subtract half of these 6 bonded electrons. That means your formal charge is 0. What is the formal charge of nitrogen of NO2 minus? Your answer is going to be C. What is the electron arrangement of a molecule that has a central atom with 2 lone pairs and is bonded to 3 atoms? Let's take your central atom as A and the other atoms as B. You have 3 of them and you have 2 lone pairs. So remember, the question asks for electron arrangement, not the shape of the molecule. Don't get confused between these two. When you have 5 things around your central atom, your electron configuration, electron arrangement is going to be trigonal bipyramidal. Why do you call trigonal bipyramidal? Because by means 2, you have 2 pyramids and your base looks like a triangle. So that's why you call it trigonal bipyramidal. What is the shape of a molecule that has a central atom with no lone pairs and is bonded to 3 atoms? So your central atom is A, the other 3 atoms are B, and you will see this is because no lone pairs, and you are going to make a trigonal planar shape. Trigonal means triangle, and all 3 atoms are in one plane. See, and this is why you call it a trigonal plane. And this is asking for shape. What is the shape of this molecule? So when you see this, you identify Cl as your central atom and it is bonded to 5 fluorine atoms. So when you look at chlorine, it's in the 7A group. That means it has 7 valence electrons. When you have 1, 2, 3, 4, 5, 6 things around a central atom, it has an octahedral electron arrangement and it has 1 lone pair, and your shape is going to be square pyramidal. Why it is called square pyramidal is that you have a pyramid shape on the top and your base looks like a square. See, this looks better, and your base is square and you have a pyramid. That's why you call it square pyramidal. You can read the textbook in the page 380 and for more information. According to valence bond theory, what is the hybridization of a central atom that has 2 lone pairs and is bonded to 3 other atoms? So when you have 5 things around, that means 2 lone pairs and 3 other atoms. This one has 5 things around. The electron arrangement is trigonal bipyramidal. When you have trigonal bipyramidal, the hybridization is sp3d. Normally, when the central atom has to accommodate 5 things, it must hybridize 5 atomic orbitals from its valence shell. So you have 5 things around, you need 5 orbitals. Let's count number of orbitals in this hybridization. sp3d, S has 1 orbital, 3, P has 3 orbitals and D has 1. That makes total of 5 orbitals. That's how you figure out what the hybridization is. 5 things around, 5 hybridized orbitals, sp3d. According to valence bond theory, what is the hybridization of oxygen in water? First, we are going to draw your oxygen and 2 hydrogens. This is your water molecule. If you don't know how to figure out how many lone pairs are on oxygen, this is how you do it. You have 6 valence electrons on oxygen. This is mainly focused on the central atom. And you are going to count non-bonded electrons. Non-bonded electrons are the ones are not bonded. This could be lone pairs. Plus bonded electrons. Bonded electrons are the one it is given to these hydrogen bonds. So you have 6 equals X. This is the one we are going to find out. Plus it has shared 2 electrons with 2 hydrogen atoms. 2 and X equals 4. That means you have 4 non-bonded electrons. That means if you pair them up, that means you have 2 unpaired electrons. So You have 2 unpaired electrons. That will make the oxygen having 4 things around. So your electron arrangement is tetrahedral. Tetrahedral means your hybridization is sp3. In other words, to accommodate 4 things around oxygen atom, it has to have 4 hybridized orbitals. S equals 1 and P brings 3. That means 4 hybridized orbitals. This will make your answer B. According to molecular orbital theory, which of the following are paramagnetic? That means has one or more unpaired electrons. So let's analyze one by one. To this question, we are going to need to draw your molecular orbitals and see whether we have unpaired electrons. First, take A, hydrogen. Hydrogen means it is hydrogen, one hydrogen atom is bonded to the other hydrogen atom. If you write down the electron configuration, it's 1s1. That means this hydrogen brings 1s1 and this hydrogen brings 1s1. Let's count the valence electrons. Each hydrogen brings 1 electrons. That means it has 2 valence electrons. Let's go to the molecular orbital diagram. This is your hydrogen to your left. This is your hydrogen to your left. Each brings 1 electron. So you are going to draw your bonding orbital and then anti-bonding orbitals. Because this one has collectively 2 electrons, first we are going to fill up the bonding orbitals. We are going to put both electrons in bonding orbitals, and anti-bonding orbitals has 0 electrons. So let's calculate the bond order. This is not relevant to the question, but let's take this opportunity to calculate the bond order. Bond order equals bonding electrons minus anti-bonding electrons over 2. So you have 2 bonding electrons and 0 anti-bonding electrons, and you are going to divide it by 2. That makes 1. And let's take your next one. H2 plus. So simply we draw the molecular orbital diagram for H2. One thing you can do is take off 1 electron. That makes your H2 plus. Or we can go from the beginning and let's count the valence electrons. Each hydrogen brings 2 electrons. Since it is plus, we are going to take off 1 electron. That means this one has just 1 electron. So this 1 electron goes in the bonding orbitals. And then let's calculate the bond order as well. You have 1 bonding electron, you have 0 anti-bonding electrons, and you are going to divide it by 2. That makes half. So as you can see in this diagram, you have just 1 unpaired electron, and your answer is H2 plus. If you have 1 unpaired electrons, that means it's paramagnetic. So let's go further and analyze these two as well. First do He2 dihelium. Okay, helium has 2 electrons in its 1s. So let's count the valence electrons for helium. This is supposed to be He2. Okay, dihelium. Each helium brings 2 electrons. That means we have 4 valence electrons. When you draw the molecular orbital diagram, so we are going to put 2 electrons in the bonding orbitals, and we have remaining 2 electrons that goes in the anti-bonding orbitals. So if you count the bond order, so we have 2 bonding electrons, 2 anti-bonding electrons, and over, and excuse me, here you should divide it by 2, not 0. Okay, and the answer is 0. When something has a bond order of 0, that means it does not exist. So but our question is He2 2 plus. Let's go to He2 2 plus. the simple thing you can do is you can take off these 2 electrons and it will make you He22 plus, or we can go from the start. He22 plus, this is supposed to be He22 plus, okay, and has valence electrons. Each He brings 2 electrons, and because it's 2 plus, we are going to take off 2 electrons. That means it has only 2 electrons. Those 2 electrons go in the bonding orbitals. If you calculate the bond order, you will see it's 1. And this one doesn't have any unpaired electrons as well. So your answer to this question is B. So this is the end of the practice questions, and I wish you good luck with the exam. Please let me know if there are any questions. Thank you.